All right, so we're diving into some really cool stuff today, and I think this is going to be particularly interesting for those of you out there who are really in the thick of it with AI and neural networks.
Yeah, definitely a lot to unpack here.
We're going to be taking a deep dive into this paper about strategic chain of thought prompting, which is also called SCOT,
Yeah,
and it's all about getting LLMs to reason more effectively.
it's really exciting stuff.
It really is. I mean, we're all constantly looking for those breakthroughs, and this might be one of them,
I think so, for sure.
especially when it comes to those more complex reasoning tasks where traditional methods just kind of hit a wall.
Totally. I mean, we're always trying to get our models to be more reliable,
Mm,
more robust in their reasoning, and it can feel like we're constantly hitting that ceiling.
yeah, exactly.
Yeah.
So for anyone who's ever wrestled with traditional chain of thought prompting,
Yeah,
you try to get the LLM to break down its reasoning step by step. It seems like a good idea in theory,
right.
but
In practice, it can be a little messy.
yeah, it can be a bit of a wild ride.
Yeah. You get these different reasoning paths, and they can lead to really different accuracy levels.
Right.
So it's tough to predict what you're going to get.
And that makes it really hard to rely on when you're trying to build AI systems that need to perform consistently in the real world.
Yeah. You need to be able to trust the output.
Exactly.
Think about it like this. Would you trust a calculator that sometimes gives you the right answer and sometimes just throws out random numbers?
Absolutely not.
No way.
Consistency and accuracy are key, especially when we're talking about really complex reasoning.
Right.
So how does Scott, this new approach, how does it actually tackle this inconsistency problem?
So Scott has this really clever two-stage approach.
Okay.
First, it tries to get a specific problem-solving strategy from the LLM,
Right.
and then it uses that strategy to guide how it generates the actual chain of thought.
Oh, I see. So instead of just letting the LM wander around in the reasoning process, we're giving it a roadmap.
Exactly, yeah, like a set of directions to follow, much
Yeah.
more structured.
I like that. And I'm guessing this all happens within a single query.
You got it. Single query technique all the way.
So no need for those back and forth prompts or tapping into external knowledge bases.
Nope. Scott keeps it nice and streamlined, efficient, reduces that computational overhead, and ultimately saves you a ton of time and resources.
Well, that's music to my ears.
I know, right?
Now, you mentioned something earlier that really piqued my interest, this idea of strategic knowledge.
Right.
What exactly is that, and how does it fit into this whole Scott framework?
So strategic knowledge is really the heart of Scott. It's not just any old problem-solving method.
Okay.
It's about picking the most efficient way, the most accurate way, and the way that avoids any ambiguity.
So it's like choosing the right tool for the job.
Exactly. For example, let's say you're working on a math problem.
Okay.
Strategic knowledge might mean choosing to use a nice, concise formula instead of trying to brute force the calculation.
Right.
Or in physics, it might be about selecting the most relevant formula to get to the solution.
So working smarter, not harder.
Exactly.
Choosing the path of least resistance that still gets you to the most reliable answer.
That's the goal.
Okay, so I'm starting to see the power of this strategic knowledge, but can you give us a concrete example, something that our listeners can really grab onto?
Sure. The paper gives a great example from math.
Okay.
The problem asks you to compute the sum of all integers such that negative 26 is less than 24.
All right.
Now, you could technically solve this by pairing up the integers, adding them until you reach the middle.
That sounds tedious.
Yeah, and pretty error prone.
Yeah.
But that's where strategic knowledge comes in. Instead of that brute force approach, you can just use the arithmetic series, some formula.
Right.
Boom, much more direct, much more reliable way to get to the solution.
So in this case, that formula represents the strategic knowledge.
Exactly. It's the smarter tool for this particular job.
Gotcha.
And that's really what Scott is all about, guiding LLMs to identify and use that kind of strategic knowledge.
I see. Okay, so we've got a grasp on strategic knowledge. But how is it actually integrated into this Scott framework? What does that look like in a practical sense?
So Scott uses a structured prompt template.
Okay.
This template includes things like defining roles, outlining a specific workflow for the LLM to follow, setting up some rules for the solution, and of course giving it the actual task input.
Right.
It's all designed to make sure that the LLM first figures out and then applies that strategic knowledge.
And this all happens within that single streamlined query we were talking about.
That's right. Efficiency is key here.
I love it.
But there's another layer to Scott that I think you'll find pretty interesting. It involves using few-shot learning in a really clever way.
Okay, now you've got my attention. Tell me more about this few-shot angle.
So imagine using strategic knowledge, not just to solve problems, but to actually pick the most relevant examples to teach the LLM.
Interesting.
It's like curating a masterclass in problem-solving strategies.
I like that. So instead of just throwing any random examples at the LM, we're being super selective.
Exactly. We're choosing the ones that really showcase strategic thinking.
Okay, I'm with you.
And it's a two-stage process. First, you create something called a strategy-based demonstration corpus.
Right.
You basically use Scott to generate answers for your training data, but you only keep the question-answer pairs that show good strategic knowledge being used.
So you're basically cherry picking the best examples, the ones that really exemplify this kind of strategic thinking.
Right, we're finding those rock star examples.
I love it.
Then when it's time for the model to actually make a prediction, you give it a new problem.
Okay.
It generates strategic knowledge for that problem just like before.
Gotcha.
But then it goes on a little treasure hunt in that demonstration corpus we created,
Oh, interesting.
looking for the examples that best match the strategy it came up with.
So it's like the LLM is saying, okay, I've got my strategy now. Let me find some examples that show me how to really nail it.
Exactly. It's like learning from the pros.
That's cool. Now, the big question I'm sure everyone's wondering is what kind of results are we actually seeing with this approach?
The results are really impressive. I mean, we're talking about big improvements in accuracy across all sorts of reasoning data sets and LLMs.
Oh.
For instance, they saw over a 20% jump in accuracy on the GSM-8K dataset and over a 24% improvement on the tracking objects dataset. And that was even with the Llama 3.8b model.
Those are some serious gains.
Mhm.
And those are models that many of our listeners are probably familiar with, maybe even using in their own work.
Exactly. And here's the kicker. Even the few-shot version of Scott, which they call Scott One-Shot, still consistently beats other baseline methods.
Wow.
So even with just a handful of examples, Scott can really boost those reasoning abilities.
That's amazing.
Yeah.
Now, we've talked about the concept of strategic knowledge, the few-shot learning, and these really impressive results, but I think it'd be super helpful for our listeners to actually see how Scott reasons through problems.
Agreed. Let's dive into some specific case studies that really highlight Scott in action, especially in areas that are relevant to what our listeners are working on, like math and multi-hop reasoning.
Yeah, the paper has some great case studies in Figure 6. And since we're talking to folks who are deep in the AI world, let's focus on a couple of examples from math and multi-hop reasoning, because those are areas where having strong reasoning is super important.
Definitely areas where a lot of our listeners are really pushing the boundaries.
Right. So one math problem that really shows how Scott shines is this one about calculating how many days it takes a frog to climb out of a well.
Oh yeah, the classic frog in the well problem.
Exactly. So the frog jumps up each day, but then it slips back a bit at night.
Right.
And what's interesting is that a traditional COT approach might just get caught up in the adding and subtracting of the jumps.
Oh, I see.
And it misses a key detail.
What's that?
That on the final day, when the frog reaches the top, it doesn't slip back down.
Oh, right, of course. It's one of those little gotchas that can trip up a model. Exactly, but Scott, with its focus on strategic knowledge, it doesn't fall for that trap. It approaches the problem by setting it up as an inequality,
Okay.
thinking about all the constraints and then systematically working towards the right solution.
So it's not just about blindly following steps. It's about actually understanding the nuances of the problem.
That's the key. And then shifting gears to multi-hop reasoning, which is a real challenge for traditional LLMs.
For sure.
There's this example in the paper that asks whether shrimp scampi is definitely free of plastic.
Interesting one.
Yeah, so a traditional co-eat approach might just look at the surface level. Okay, plastic isn't listed as an ingredient, so it must be plastic-free.
Right, but there's more to it than that.
Exactly. There could be contamination during processing or packaging.
Yeah, that's a good point.
But Scott, it being all about strategy, it considers the bigger picture and comes to a more accurate and nuanced conclusion.
It's almost like Scott is teaching the LLM to be more skeptical in its reasoning.
I like that. Not just taking things at face value, but really digging deeper. And there's another multi-hop reasoning case that really highlights how important choosing the right strategy is. It's this physics problem where a traditional coat might see the word capacitor and immediately jump to the wrong formula.
Oh, so it's getting hung up on a keyword and not really understanding the underlying physics.
Right, but Scott, because it's focused on selecting the most appropriate strategy, gets the right formula right off the bat. And that leads to a much more accurate solution.
These case studies are really helpful. I think they really show how Scott can handle those tricky reasoning situations that often trip up those traditional LLMs.
Definitely. And speaking of handling things, I'm wondering, does all this strategic thinking come at a cost? Is there a trade-off in terms of efficiency?
That's a great question, and it's something the researchers looked into. Since Scott generates a strategy before solving the problem, it's definitely more efficient than those multi-query approaches that require going back and forth.
Right.
But compared to just simple single-query methods, the output might be a bit longer because it includes that whole strategic explanation. So is it a balancing act then between accuracy and processing time?
It can be, but the thing is, we're not talking about a huge difference in processing time. If you look at Table 4 in the paper, which compares token length, you'll see that in some cases, Scott actually reduces the token length compared to other methods.
Really?
Yeah, so it's not always a trade-off. And even when the output is longer, it's usually only about 1.5 times longer than traditional COTI.
Okay, so not a massive increase.
Nope. And I think given the big accuracy boost we're seeing, it's a pretty reasonable trade-off.
I agree, especially when you think about the potential impact on the reliability and robustness of our AI systems. Now, one thing that really struck me about this research was the exploration of automatically generating Scott prompts using LLMs. That sounds incredibly powerful.
Oh, yeah. That's a really exciting direction. I mean, imagine being able to just give your problem to an LLM, and it would not only solve it using Scott, but also figure out the best prompt for doing so.
That would be a game changer. It would make Scott so much more accessible and user-friendly.
Absolutely. More people could use it even if they're not prompt engineering experts.
Exactly. And the researchers actually did some initial tests on the Aquaway dataset.
Right.
And they found that while the accuracy wasn't quite as high as with those manually crafted prompts, it still outperformed traditional zero-shot CTT.
Pretty promising.
Definitely. Very promising.
Yeah.
Now, before we get too carried away with all the future possibilities, I want to bring it back to our listeners who are actively developing AI systems. How can they take these insights and apply them to their own work?
That's the million-dollar question. The great thing about Scott is that it's not just some theoretical idea. It's a practical framework you can use right now.
So it's not just research for research's sake.
Nope. It's about solving real-world problems.
That's what we like to hear.
Think about the specific challenges you're facing in your own AI development. What kind of reasoning tasks are giving your models a hard time? Where are you seeing inconsistencies or limitations?
It's about identifying those areas where our current methods are coming up short.
Exactly. Once you've figured out those areas, then you can start thinking about how Scott might be able to help.
Okay.
What kind of strategic knowledge would be super valuable in your domain, and how could you structure your prompts to get that knowledge out of your LLMs?
I'm already picturing our listeners' wheels turning. It's where it all comes together. Cutting-edge research meets real-world impact.
And don't forget about the power of few-shot learning with Scott. You can create your own strategy-based demonstration corpora that are specifically tailored to the challenges you're facing.
It's like giving your models a personalized training program to really hone those reasoning skills.
That's a great way to put it. This is exciting stuff. But as with any new approach, there are always questions, challenges, and new avenues to explore. I'm curious what you think about those ablation studies mentioned in the paper. What did we learn from those about how Scott actually works?
Yeah, those ablation studies are always so interesting. I mean, they really help you figure out what's truly essential.
Right, exactly. The researchers wanted to see which parts of that Scott prompt template were the real workhorses.
Right, the ones that were driving those big improvements in accuracy.
Exactly.
So they played around with different parts of the template, like the roles, the workflow, the structure, even the number of demonstrations used in the few-shot learning. What did they find?
Well, it turns out that pretty much every element played a role in boosting that accuracy.
Really?
Yeah. Adding those roles to the prompt, making sure the workflow is well defined, even just formatting the prompts, using Markdown, all of that led to better performance.
So it's not just about the big picture, it's also about those finer details.
Exactly. The little things add up.
And what about the number of demonstrations in that few-shot setup?
They found that more wasn't always better.
Makes sense.
Sometimes increasing the number helped, but sometimes it didn't really make a difference.
So it's all about finding that sweet spot.
Right. Giving the LLM enough examples to learn from, but not overwhelming it.
Before we wrap up, I wanted to go back to something you mentioned earlier about how cool it would be if LLMs could automatically generate those Scott prompts. Where do you see this technology heading in the future?
Oh man, the possibilities are huge. I mean, imagine a world where you just give your problem to an LLM, and it not only solves it using Scott, but also figures out the absolute best prompt for doing that.
That would be amazing. You would make Scott so much more accessible to a much wider range of developers and researchers.
Totally. We could see a real explosion of innovation as people from all sorts of backgrounds start experimenting with Scott and applying it to new and challenging problems.
Yeah, I mean, we've already seen how Scott can tackle those complex reasoning problems, from math and physics to common sense reasoning and multi-hop reasoning. But this is just the beginning.
Absolutely. There's so much more to explore, and I think that ability to automatically generate those Scott prompts is going to be key to unlocking that potential.
As we move forward with Scott research and development, I think it's really important to keep in mind the practical needs of those who are going to be using it in the real world.
Absolutely.
We need to make sure that Scott is not just powerful, but also user-friendly and scalable.
Right.
We want to make it easy for developers to integrate Scott into their projects and to use it to build truly intelligent and reliable AI systems.
I think a big focus is going to be on developing those tools and resources that can help developers craft effective Scott prompts and put together those strategy-based demonstration corpora.
Yeah, having those clear guidelines and best practices is going to be so important.
Absolutely. And personally, I'm really excited to see how Scott can be used in more interactive and conversational AI systems.
Oh, that's interesting. Tell me more.
I mean, imagine chatbots or virtual assistants that can actually reason effectively and have those more nuanced and meaningful conversations.
It would be a huge shift in how we interact with AI.
Totally. It would make those systems so much more capable and helpful in our daily lives.
And as we start moving towards more collaborative AI systems, systems that can actually work alongside humans to solve those complex problems.
All right.
Scott is going to be so important in making sure that those systems can reason well and really contribute to the task at hand.
I'm picturing a future where AI systems powered by Scott are not just tools, but actual collaborators. They can understand our intentions, anticipate our needs, and help us achieve our goals.
That's an amazing vision, and I think it's definitely within reach if we keep pushing the boundaries of Scott research.
Definitely. And as we go on this journey, it's important to keep the big picture in mind. Why are we so passionate about advancing AI reasoning?
It's about creating AI systems that are not only intelligent, but also trustworthy. Systems that can help us solve those really tough challenges facing the world and create a better future for everyone.
Exactly. We're not just building algorithms, we're shaping the future. And Scott is a really powerful tool that can help us build that future on a foundation of ethical and reliable AI.
So to wrap up this deep dive into the world of Scott, I want to leave our listeners with a challenge, an invitation to join us on this journey of exploration and innovation.
Yes, embrace the power of strategic thinking. Play around with Scott in your own projects, and let's work together to build AI systems that can understand reason and make a positive impact.
This has been a fantastic conversation. I've learned so much from you today.
It's been a pleasure. I always enjoy these deep dives. It's so inspiring to see the passion and dedication of everyone working at the forefront of AI development.
To all our listeners out there, keep pushing the boundaries, keep innovating, and let's build a future where AI benefits everyone.
Absolutely. Until next time, keep exploring and keep learning. The future of AI is in your hands.